There's two platforms here. If you're running training, you're using Slurm. And if you're running inference, you're running on Kubernetes.
What's next? Storage. And perhaps semantics ties back to your token comment.
The quantum computing potential threat to Bitcoin and cryptocurrency. And that threat can be divided into two pieces. And one piece is the hashing itself on the main blockchain.
I think if you're a storage company, you probably want to take that comment very seriously.
Welcome to the OrionX Download Podcast. Join Shaheen Khan, the OrionX analysts, and special guests as they discuss and simplify the big ideas in technology that are changing the world. Thank you for being with us.
Hi, everybody. Welcome back to another edition of Analyst Roundtable, i.e. ART, i.e. art. So we are providing the art and science and technology all in one podcast. This is Shaheen Khan. Together with me is Adrian Cockcroft, Chris Cruel, and Stephen Perino. Thank you, gentlemen, for being here. How are you?
Pleasure to be
Doing
here.
well, thank you.
All right. So without further ado, GTC was last week, and we teed it up in our last episode. Adrian, you were there in person. I was there in person. You guys tracked it quite closely. So maybe you want to tell us your take on it.
Yeah, I was there last year and wrote a story where the theme was that I thought what they were releasing was giving most enterprise customers indigestion, trying to consume the sort of technology that's coming out, big water-cooled racks and things like that. But I thought the hyperscalers were happy that they have these super powerful systems. So this year, I sort of took that story, went over it, looked at what had been announced over the intervening year, which is actually quite a lot of announcements happened during the year, and then looked at what was announced in the keynote and decided that the hyperscalers also have indigestion now. In particular, AWS has not actually ended up announcing there are no public Blackwell-based product lines. They're obviously taking Blackwells and supplying them to customers, but they're not doing it on the public price list as a standard device type. So it's an interesting time where these very hot, high-powered racks are just hard for everybody to deal with. And what Jensen did in his keynote was in some ways trying to lay out more of a roadmap into the future with fewer surprises to give people a few years warning of what's coming. And also just lots of different packaging options for enterprise air-cooled systems, things like that, to just make it easier to consume the technology that they've got. So that was my idea of the theme of what was going on. Some people were disappointed that there weren't any sort of massive new announcements. And I think the biggest surprise announcement was their photonics systems. They have a very cool optical connection chip where they land the lasers directly on the chip. And there's some big water-cooled racks with 500 ports kind of capacity. So that was the only sort of brand new thing. The rest of it was more just saying, this is what's coming down the road. You're going to have to deal with it. We've got 130 kilowatt racks now. That's going to go up to like 160 something kilowatts soon, and then in the same rack, and then maybe more with the Rubin chip in the same rack, and then another rack with 576 Rubins in it in a single rack, which is going to be at least 600 kilowatts, maybe even 800 kilowatts in basically a single rack. And they had a prototype of that rack that they're building out now. So that's kind of the warning. 2 or 3 years time, build your data centers to take ridiculous amounts of power per rack. And if you can't do that, then you're not playing in the game. I think that was kind of the messaging that I got from it. What do you think, Shaheen?
So the question is, how many of those do you need? Because if you have a big system like that, then maybe for on-prem anyway, 1 or 2 might be enough. But if you're a cloud provider, then you better start looking for another nuclear power reactor. You had some side trip to look at energy sources. Do you want to tell us about that?
Yeah. Last month, we talked about a story I got involved in that CNBC ran on alternative energy for data centers. And one of the companies they featured was ECL, who have a hydrogen-powered option, which is currently fairly low capacity, but they have an up and running megawatt scale data center in Mountain View. And I was contacted to say, do I want to come and have a look at it? So I went and had spent an hour or so with Yuval Bashar, who's the CEO, a really interesting guy. He's run big data centers. And he had, in that data center, I was surprised to find 2 of the Blackwell NVL72 racks, powered up, running on their water-cooled systems. And one of the things I found interesting was that they aren't just water-cooled. the rack has about 30 kilowatts of air cooling on top of its roughly 100 kilowatts of water cooling. So you have to air cool the racks and water cool them at the same time. And they were just sitting there making a lot of noise. It's not a quiet place to be. But so it was interesting to actually see, and this is a production rack that was running on behalf of one of the GPU cloud providers, all powered by a single pipe of carrying hydrogen into the building, and they pipe it in from outside. They have a supply of carbon-free hydrogen assured for the next whatever capacity they need. They're building a data center down in Texas that's where a bunch of hydrogen pipelines converge, so they've got multiple suppliers. The story actually made more sense talking to him personally than I'd picked up through the CNBC recording. They seem to have got most of the things covered. But the main issue is it's like their unit size for their generators, roughly a megawatt or so, and that's a bit on the small side. They'd need a large number of them to run a large, they'd need to replicate their little installation rather a lot of times to do a large scale data center. So that's really and they're working on scaling up as well as scale out. The interesting visit to actually see a real one.
Steve, Chris, you guys have any take on GTC? I have a few more thoughts too afterwards.
Yeah, just I want to circle back to the Spectrum X photonics announcement. Photonics and optical interconnect has been a long time coming. Just kind of curious whether you guys think this provides a tipping point for photonics in interconnect. I mean, the power savings here, energy savings, about 3.5x, I think they said. That's not insignificant, but you balance that against the power needs of the GPUs that are coming out. It starts to become a bit of a wash, but you'll take every little bit you can get.
No, I thought it was the star of the show too. And it brings optical networking into a new realm as a cluster interconnect. And it obviously more than doubles the performance as realized and eliminates a bunch of transceivers. So it has benefits there. And I think it is a bit of an inflection point in that market.
I think it's the cost was the main issue. If you look at building out one of the sort of 500 GPU kind of clusters, because the interconnect that you want to use with NVLink is lots and lots of wires because it's super high bandwidth, but it's copper, so you can only really go to the next rack over. And
Right.
if you want to put 8 or 16 racks together, you end up needing optical to interconnect it. And then the transceivers, particularly for NVLink, where you've got an enormous number of lanes that you're running to get the bandwidth, you just end up with a very big transceiver bill and very cumbersome cabling to do it over copper. So there's two paths here. One is you make the transceivers cheaper. I mean, you can obviously do it with InfiniBand, but that is lower bandwidth. You're using there's fewer lanes going down between each system. But what they really wanted to do was use an NVLink interconnect, which is 1.8 terabytes per second over the link, and do that optically. And so, or even very, very large clusters of InfiniBand, the large scale clusters, you spend a lot. It's like $1,000 or something per transceiver. So this way, the switch itself takes the fiber in and lands the fiber directly on the switch chip, cuts out a huge amount of cost and complexity. And then the other thing is having a 512 radix switch, so you can do a very large cluster with just one or two hops, right? So that the number of ports on your switch really drives the scale of the cluster you can build. So they're shooting high, and it's all water-cooled switches. We're not just up to water-cooled compute now, we're up to water-cooled switches. So that's an interesting point.
Steve, any comments?
Yeah, well, there was a lot of discussion by Jensen about the scale up versus scale out issue. And, we've all been involved in our careers now for decades in the whole issue of scale up versus scale out. And there's always a role for both. And, the best architectures are hierarchical. They have to be. It's the only way to be efficient, just like the best software architectures are hierarchical or have layers. And it's always a trade-off. But, at the core of these AI algorithms, you have matrix multiplies, which are things that we've been doing in scientific computing now for, half a century, more than half a century. And so it's always been a driving problem as to how you could kind of do the nesting of scale up versus scale out, and then have sufficient memory bandwidth, at the different levels of the memory hierarchy. I think they've taken a very nice approach. And, we just want to remind people that it's not a completely new concept.
Far from it, really. Yeah. So along those lines, I thought the first half of his talk was an explanation of, if not a justification for, the strategy. And it was trying to build a case on why we are trying to solve this problem this way, and why all this problem with switching and latency and big GPUs and power and cooling, why this is like really the best way to go solve it. Because there are alternative approaches that don't have those problems. So he started out with what I call tokenomics. It was like, let's use the word token every other word for the next 5 minutes. Token, 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 more token. And it was like, okay, this is the new currency of generative AI. And as we go from generative AI to agentic and then physical AI, and that was a nice roadmapy kind of a thing. And then we go from learning to inference. I think one point he made was we need a lot of tokens and a lot of tokens per second. And then we need it to be like 10 times more and 10 times faster. So that gives you 100x for the next step that we want to do. So it needs to be that much faster. Basically, inference is a lot more compute intensive than we thought, than you thought.
I think that was the point there, was the agentic. Like if you're just saying, is this a cat or a dog, that's a certain type of inference, right? And then you do the kind of, can you write me some code that solves this algorithm, and it writes you the code. But the latest systems, you say, I have a problem, please solve it. And it iterates, it thinks about it. There's an agent, there's a bunch of agent planning going on. It thinks about it, it tries a few approaches, it maybe even runs your code for you, and looks at the error messages and then fixes it and says, okay, that looks reasonable. I've been using Cursor with the Claude 3 Sonnet 3.7, whatever, thinking mode, whatever it's called. And there's basically a button you push called the YOLO button, where it says, yeah, just run stuff until you're done. And it just sits there and executes stuff on its own little command line running code. And it's been pretty impressive to see what you can build with that. But certainly the amount of tokens being generated for that is vastly more than the single shot kind of thing that we've been seeing, in previous years. So
right, because now you have to generate a lot and then pick the ones that actually work and you like. So as you go from pattern recognition to generation to reasoning to now actually embodied physical, he was saying that you're going to need orders of magnitude more as you go forward. And then he kind of concluded that in order to do that, you need to scale up before you scale out, which is very consistent, as Steve mentioned. I remember in the old days, and we're talking a few decades ago, we had a big data center. It was like an international data center, and they had like 800 mainframes, small mainframes, but mainframes nevertheless, which continue to be the proverbial example of centralized computing. But if you have 800 of them, is this central or is this distributed? Is this a cluster? So the conclusion was very obvious that it's always a cluster. The question is how many nodes and what is the size of the nodes? And NVIDIA has taken the approach of really big fat CPUs in really big fat systems in really big fat clusters. And they made a case. And then they talked about the workload as you go to inference. And you had a whole rainbow coalition of different types of applications, each of which would have a slightly different requirements for the system. And if you want to be able to do any of those at any given time, then further evidence why you need a big fat GPU to do all of that. So you put the four of them together: tokenomics, inference, scale up, workload, and that was the justification for, okay, now get ready for Rubin Ultra NVL 576.
And the other piece that I thought was quite interesting really was this Dynamo scheduling system that's aware of all these layers. Your cluster data center or the AI factory, all being managed by this single system that it's not really a full operating system, but a well-developed scheduling system. And along the lines of what had been a vision for us at Sun Microsystems with N1, and
exactly,
it could never really be fully realized. And it now seems like maybe he's realized that. So that was quite an interesting announcement.
It was a good announcement, and they said it was going to be open source. And I looked on GitHub, and it wasn't there then. And I just looked again, and it's still not there like a week later. So, they do have to actually open source the thing that they were talking about to really get everyone to look inside it and see what does it actually do. But definitely, I think that the key thing is that NVIDIA's software stack, it's not all about the hardware. You've got to have the software stack. They have versions of CUDA for every different application area you might be involved in, on a software stack that actually works when you try and do it. And the biggest problem the competitors have right now is that, they kind of have the same software stack, but when you go and try and use it, it's a lot buggier, hard to install. a lot more issues in the system. So, everyone's sort of pushing harder to try and use like an AMD chipset and that whole stack than just using the NVIDIA one. So they've got like the software makes the hardware usable. They've just got a much better application stack for AI based on NVIDIA. And that's everyone's now fighting to try and port that across or make it more usable. And it'll mature and eventually it'll be more generally available. But right now, this is still the sweet spot. Well, I think there's two platforms here. If you're running training, you're using Slurm. And if you're running inference, you're running on Kubernetes. And those are the two underlying platforms that are operating the GPUs. And if you go to, say, CoreWeave's site, those are the options you get. You can run either one, and it's nicely integrated, and it's all relatively easy and straightforward to use and reliable. And that was one of the other sort of things that's been coming up recently is the traditional cloud providers are just having more issues supporting these workloads, and CoreWeave, Lambda Labs, people like that, Crusoe, are doing a better job of putting out the software stack for building these AI applications because they've been able to do it from first principles. Actually, CoreWeave interest might be worth chatting about a little bit because Semi-Analysis just released a story that tried to rank all the GPU providers, and they put CoreWeave at the top as the most functional one, and everyone else sort of somewhere in various layers below that. I wonder what people thought of that story.
Yeah. I think the Slurm and Kubernetes is a great way to look at this. And NVIDIA has done a couple of acquisitions over the past several years that are aligned with that. One was Bright Computing. That was just a traditional HPC cluster workload management provisioning sort of a piece of software. That was a few years ago. And then just recently Run.ai, which was a little bit more focused on AI orchestration. And looks like both of those are part of what has now become Dynamo. All right, the other thing that came out in GTC, just as Jensen was finishing the talk, he talked about storage and mentioned the word semantic storage. And that, I think, is a pointer to what we might expect from them over the coming years, as they have systematically gone beyond chips to systems, to interconnects, to software, to system software, to application software, platform software, and now storage. So if storage is becoming more and more computational, erasure coding is computational protection. As things become more computational, they become more amenable for AI enablement. So he was talking about how AI can just get you the data that you want.
Yeah, I think he was talking about intelligence in the storage tier as one thing, but also people are using HPC file systems like Lustre as the way you feed these GPUs with the data sets that you need. So that's I think the areas around storage. It was a fairly small section of the keynote, so I kind of
so it was hard to tell how much to read into it. Was he just teeing up some big announcement later on? I think if you're a storage company, you probably want to take that comment very seriously.
Yeah, for sure.
Well, I think his main point was semantics.
Yeah.
The ability to use semantics to access objects and support generative AI and agentic AI in their semantic functions, right? As the generative AI is exploring, problem solution and putting that out to the client, its train of thought. That's a very heavily semantic kind of activity, right?
Right.
So if somehow you can architect capability and the storage, to map into that could be powerful.
Yeah, and I, just stepping back and taking a very high level look at it, you can't help but be impressed with the ecosystem they've built up over the years, right? And Adrian was speaking to that earlier. And okay, what's next? We've ventured into cluster interconnects and therefore the network. And now what's next? Storage. And perhaps semantics ties back to your token comment, Shaheen, just trying to chunk data and access it as easily as possible. Just makes sense. These guys they're on a roll here.
Yeah.
That's the old Craig quote that supercomputer is a machine that turns a compute-bound problem into an IO-bound problem.
Right. That's right.
That's the rolling definition of a supercomputer.
So as we exit the GTC topic, one other news was that NVIDIA is running production off of TSMC's Arizona factories. So those, of course, are wafer oriented and they generate chips, and it's good to see them in production. But then they probably have to get shipped to Taiwan to get packaged, because all the leading edge packaging is done out there. And then, as far as I know, the supply chain includes a swing through mainland China to turn it into shippable product with the final packaging and assembly. So the supply chain continues to look pretty complicated. All right, if no comments, let's go to quantum computing. Well, of course, that brings us right back to GTC2, further evidence of the ecosystem. But Jensen had a quantum day, and he had two separate sessions, each with a half a dozen executives, senior execs of various quantum computing companies. And they just sort of discussed what was going on in the market and when to expect what. At the same time, they had technology transfer and training sessions on the site that day that included a bunch of universities and additional quantum computing companies, also emphasizing NVIDIA's own software in quantum computing between Q Quantum, which is CU Quantum, and CUDA Q, which is CUDA dash like Q, the letter Q. And one of them is the backend simulation of quantum applications, and the other one is the orchestration of the hybrid classical quantum setup. And to this day, really, where these quantum-inspired algorithms and quantum algorithms run is on NVIDIA GPUs with typically really large memory as well. So they're definitely participating in that market, albeit without an actual quantum computer. So they made several announcements there that were, of course, tied with that session. NVIDIA is setting up a research lab in Boston together with Harvard and MIT and a few quantum computing companies focused on quantum classical hybrid computing, which is really where the HPC market is going rapidly, as evidenced by big supercomputer centers at DOE centers, Oak Ridge National Labs, and Sandia, and others, as well as in Europe at places like Jülich Supercomputer Center in Germany. And of course, RIKEN in Japan is doing it too, but they're not based on NVIDIA system. They're based on the system that Fujitsu built that is a different strategy. I want to talk about performance achievement in quantum computing, and there are a lot of quote benchmarks that are being released that are really in the category of system characterization. So essentially what you need to get performance out of quantum computing is so-called circuit size and circuit depth. Just how many things can I do in a quantum computer, and can you run the program that might have so many different things that it needs to do. And that also means what is the speed of these transformations that you need to do, and what is the nature of those transformations? Because depending on the kind of quantum computer you use, some transformations might be slow and some might be fast, or some not even available. And now, in order to get to that, you need number of qubits. Because you have errors, you need number of logical qubits. Even logical qubits have errors, so you probably need some safeguards on top of that. And then you need connectivity between these qubits. And then the connectivity can happen on one chip or kind of clusters of chips, and people are pursuing different strategies to do that. So as I like to say, the progress is really very real, but the hype is also pretty real. So you have to be careful, and that's really hard to do. There were announcements also about cryptography. The UK government has guidelines on when to go to post-quantum cryptography and quantum resistance cryptography algorithms. Their timelines are almost exactly the same as what NIST in the US has been advocating, and the legislation that's going through the regulatory system in the US. Basically, by 2028, figure out what you need to do. By 2031, be implementing, and by 2035, be done. And that time frame actually matches other analyses that have been done in terms of when Shor's algorithm can crack codes and factor really large prime numbers. That would be like the time frame when that could happen. If they're lucky, maybe faster. If they're unlucky, maybe there's a setback. But it seems like a reasonable stake in the ground. And if you get done earlier, of course you should, especially if you have really high value data. Maybe this is a good segue into cryptocurrency and Bitcoin and a bunch of the research that, Steve, you've been doing.
Yes. So maybe first I'll comment on the quantum computing potential threat to Bitcoin and cryptocurrency. And that threat can be divided into two pieces. And one piece is the hashing itself on the main blockchain. of Bitcoin because that's a different algorithm. It has a SHA-256, but it's a double SHA-256, and it's a hashing form. So that's a different algorithm from what's used for your public-private key architecture, which also has SHA-256 as the typical use. And there's very little vulnerability on the hashing side, on the blockchain itself. People are not going to be able to take out coins without cracking the private keys. Some of those are exposed. Those are the very early ones, up until about 2012. So Satoshi's 1 million Bitcoin is the honeypot there, because what happened is initially, the public keys were exposed in the blocks themselves, and so you could take the public key, and if you had quantum computing that could crack it, then you could compute the private key and then retrieve or steal those coins. That was fixed after late 2011 and into 2012. Most wallets now have a later version that only exposes the public addresses when you're moving the coins. So that makes things a lot safer. It means that when the time comes, you can just move to a quantum safe wallet. Now, it may take 10 years, in the worst case, it may take 5 years until Shor's algorithm, which can attack the addresses, has sufficient power behind it. And that's going to require probably at least 1,000, more like a couple thousand or more logical qubits. And right now, the projection is in order to get that, you're going to need 1 million physical qubits, so order 1 million physical qubits. Now, there have been some advancement in noise reduction algorithms of late, announced from various people, including Google with the Willow, but others as well. And so, they're trying to solve some of the scaling problem, and they might be able to get to 1,000 or 2,000 logical qubits without fully reaching 1 million, but it's just unknown at this point because we're only at 1,000 physical qubits, right? So there's a long, long way to go. For Bitcoin, there is a proposal for a BIP. It's not fully adopted yet, but there's a draft proposal, and it supports 4 different quantum safe algorithms, and it would be a soft fork. It would not require a hard fork of Bitcoin. And so you could implement it in some sort of gradual way to allow people to move to quantum safe wallets. And once you have Shor's algorithm cracked, then the entire financial infrastructure is at risk. So it's not just Bitcoin that's on the hook. With respect to Bitcoin and how that space is developing and crypto more broadly, what we've seen is a very nice run-up in calendar years 2023 and 2024 recovery from the previous slump. And as we've seen that, Ethereum and other altcoins have not, for the most part, kept up. In fact, Ethereum relative to Bitcoin has basically been in decline since it abandoned proof of work in September of 2022. Bitcoin has run up by a factor between over 5, about 5.5, since the end of 2022. So that's not bad for 2 years of performance. And there was a lot of hype last quarter around the election and the concept of a strategic Bitcoin reserve. And then there was a little bit of slump as that didn't get announced, but it has now been announced within the last couple of weeks. And I think they've announced it in the right way. They've been a little bit cautious. So all that's happening in the first phase is all of the Bitcoin that's been seized over history has been sitting with the Justice Department, with the U.S. Marshal Service. And the U.S. has about 200,000 seized Bitcoin. And they have had regular auctions in the past and sold those off. And that's always been a bad economic decision or financial decision, as we can see from Bitcoin price history. So the decision is made to, stop doing that. And the strategic Bitcoin reserve has been established by just basically moving control of those via executive order from the Department of Justice to the Department of Treasury. So the Department of Treasury will now have oversight for that. And I don't know whether the keys will be kept, there or somewhere else. I mean, that may still be happening as to how that's worked out. And then the next phase would be to actually go out and acquire Bitcoin in the market. And there is a bill that's been proposed last year, headed by Senator Cynthia Lummis of Wyoming, I believe. And it has some co-sponsors, and she's trying to get bipartisan support for that. And it will really take an act of Congress to go out and acquire additional Bitcoin, but there's a strategy to do that. And the strategy is to revalue the gold reserves. The Treasury has owns a lot of gold in Fort Knox and held at West Point and elsewhere, about 8,000 tons. And it's all on the books at $42 an ounce. And the gold price is now $3,000 an ounce. So if they mark that to market, then they can just say, okay, that's some free money that we can use to go buy Bitcoin, which is digital gold. So that's the general idea that she proposes in her bill. There are some weird wrinkles because the Federal Reserve has gold certificates. Because what happened was Roosevelt seized the gold away from the Federal Reserve in 1933 and gave them pieces of paper instead. So they have these gold certificates and they value them on their books at $42. So the actual mechanism would be to revalue those gold certificates and have the Treasury take the profit, not the Fed, and use that to acquire additional Bitcoin. And the talk was about, and the proposal in the Loomis bill would be to acquire 1 million Bitcoin within a 5-year period. And whether that would all be incremental or whether it would be an additional 800,000, we'll have to see what a final bill would look like. But that's the general idea. Now, at the same time, they also created a crypto pool. And personally speaking, I think they did the right thing in making that separate from the Bitcoin Strategic Reserve. And so that's other seized assets, Ethereum and other coins that have been seized, and that's held by, again, the Marshals Service, and that will also move into the Treasury in this separate cryptocurrency pool. And there are no announced plans to go out and buy those assets. So I think they'll just hold those, and who knows whether they'll see capital gains or not, but they view that as supporting the broader cryptocurrency industry. They want the U.S., to be the leader in that. And indeed, we already are because, as a citizenry and in terms of mining, there's more Bitcoin held by the U.S. citizenry and by the U.S. government with the seized Bitcoin. And now we have the ETFs, and we have more than 25% of the global mining capacity for Bitcoin here in the U.S. Well, I should say publicly traded companies listed here in the U.S., some of the mining's in Canada, and some's in a few other countries, yeah.
So if you're a country, you're looking at strategic reserve, and if you're a corporation, you're looking at using some of your treasury for that. And of course, MicroStrategy famously has done that successfully. There was news that others are thinking or looking to do the same.
Yes. In fact, there are now 6 companies. There are now 60 companies that have Bitcoin in their treasuries. And that's global number, but most of them are U.S. There are a few in Japan. There are a few elsewhere. One of this, clearly, Saylor's way out front. And just as of this week, he passed the 500,000 mark. So they've got over 500,000, and they've done that in a little over 4 years, about 4.5 years, starting in August of 2020. So that's phenomenal. And some other well-known names are Mara, who was one of the biggest Bitcoin miners. Many people are aware that Tesla bought some years ago, but they have not been adding to it. And then Similar Scientific kind of went all in. They're a small biotech company. And the most recent announcement that just happened within the last 24, 48 hours is GameStop. And they're actually adopting Michael Saylor's strategy of going out to the market and raising money to buy Bitcoin. And Saylor has been doing this for some time, initially with traditional equity offerings and traditional bond offerings, but then they quickly realized that the way to go was with convertibles. And so he's been issuing convertible debt and with either zero or very low interest. And then he recently had a preferred stock offering as well. And GameStop has just announced a $1.3 billion convertible offering. So they're able to do that with close to zero interest rate And they said the intention is to use it to buy Bitcoin. So that's a very large investment, and it's going to transform their company treasury, and it's going to transform their company, because that's what's happened with MicroStrategy. They've been completely transformed
That's great.
by going to
So,
this.
Steve, let's get your take on China, because you've been looking at that as well recently. And then that is kind of part of our technopolitics topic and our opportunity to put a lot of this in the context of global policy. And China, of course, always comes up as where some of a lot of the action is. So tell us about that.
Yeah, two things. One is sort of a news item, which is relevant to what we've been talking about NVIDIA domination and GPU supply. And this is an article that just came out in MIT's Technology Review. And it says there's basically an AI data center bust in China right now. And it leads off talking about a certain individual, Mr. Lee, who was a real estate contractor turned data center project manager, who had pivoted to AI infrastructure in 2023, drawn by the promise of the Chinese AI craze. And people were bragging about securing shipments of NVIDIA H100 chips smuggled through overseas channels into Shenzhen, and that we're selling it up to $28,000 on the black market. Now the story is quite different. Prices have come back to earth. Two of the data center projects that he's familiar with are struggling to secure further funding, forcing project leads to sell off surplus GPUs. You know, China has had this big bust in the real estate industry, right? And so real estate developers were looking for other things to do to stay alive or make money. And so they thought, well, okay, data center construction, this would be a place to be. Just months ago, it was at its height, a boom in data center construction fueled by both government and private investment, but many facilities newly built are now sitting empty. Most of the companies running these are struggling to stay afloat. The local Chinese outlets report that up to 80% of the newly built computing resources remain unused. It was once seen as a sure bet, but with the rise of DeepSeek and the sudden change in the economics around AI, the industry is faltering. Largely a result of inexperienced players, corporations, and local governments jumping on the hype train and building facilities that aren't optimal for today's needs. So they didn't know what to build. Energy was being wasted, and they're now becoming distressed assets. And so it's not an unusual thing that we see these kind of boom busts in China. So that's just one report. And now another report comes from a lecture that I attended last night here in Bangkok that was run by the MIT's business school, the Sloan School. And it was a Professor Wang, who, you know, is an economics background professor at Sloan. And he's written a couple of books. One was Capitalism with Chinese Characteristics, which he wrote in 2008. But he's got a new version coming out that's going to account for some of the changes, particularly under the Xi regime, because that was very young when he wrote it, the first edition. His more recent book is called Rise and Fall of the East, and it dates from 2 years ago. But East does not stand for the Far East. East stands for characteristics of China, which are the pillars that they've built their society on. The first one is education. The second one is authoritarianism. The third one is stability. And the fourth one is technology. And it dates back to the 6th century. And that's when the civil service exams were introduced in the year 587. So this is a tradition that's been going on for over 1,400 years, and that is now still today. And it's transformed through the various empires, and through Confucianism was this kind of structure, but it still persists under communism and under the CCP. There's always been high numeracy in China as well. So there's always been kind of a focus, tilt towards the technical side, but in recent years it's become they're basically heavily populated by engineers, in the Chinese Communist Party. I mean, Xi was trained as an engineer. So what he's seeing now is a duality where there's a lot of technology power in China, and we see this with AI, with EVs, with drones. They've got 75% of the world capacity in EVs and in drones and in solar. And their scientific publishing index is now, past the US. But productivity is low, and they're struggling at the macroeconomic level. The official numbers are 5%, but the real numbers are about 2%, according to independent analysts. And so there's a conflict here. And, this is something he's studying. And one of the things that he noticed is that FDI has collapsed to nothing. It's only $5 billion in the past year. And they have not been able to restructure towards domestic consumption. It's still very low. It's only 39%. Whereas in the US, the domestic consumption share is about 70% of the economy. They are very much overproducing in some key areas, which are, we know they're producing actually, the supply from China of batteries exceeds the global demand. The supply of solar panels produced in China exceeds the current global demand. And now the supply of EVs from China, as you project it out for the next 5 years, is going to exceed the global demand for EVs. There's a real mismatch from a global supply level. And it's mercantilism that's amplified to a very high degree. And, how does the rest of the world compete with that? Where they overconsume in China is in areas primarily that are inputs into manufacturing, semis and construction and chemicals and so forth. And they underconsume the actual output of pharmaceuticals and packaged goods and health. Their debt to GDP is very high. It's 300%. It's higher than the US. It's had very rapid growth since the Great Recession, the Great Financial Crisis in 2008. Local government financing has been a lot of the debt, and most of that has been to develop real estate, and it's been hard to control. Productivity has fallen in half. There's been a very sharp decline in private sector return on assets. And the government reports are all more and more tilting everything towards the supply side rather than the demand side. So they really haven't pivoted. They just put the pedal down harder on the supply side.
So I wish we had started this topic a little bit earlier too, or we had more time, because this is all so important and so complicated, and especially in the context of the global scene and who else is doing what, and certainly all the changes that we're seeing in the US. So maybe we can tee that up for next time and get a little bit more detail around it as well. But all really excellent and relevant and further evidence of just how impactful technology is to the global scene. So if you guys are good, we can wrap this episode at this point.
Sure.
All right. Well, thank you all for listening, and we'll catch you next month.
That's it for this episode of the OrionX Download Podcast. Every episode is posted to orionx.net and shared on social media. Use the comment section or tweet us with any questions or proposed topics of discussion. If you like the show, rate, review, and share it. The OrionX Download Podcast is a production of OrionX. Thank you for listening.